This is the screencast for section 6.1, example 6. Now we're going to find the direction angle of a vector. So all we're given is that the vector in standard form is 3, 2. And I know that u equals, from the last example, the magnitude of u times the cosine of theta, or the magnitude of u, the magnitude of u times the sine of theta. So I could either use the x component or the y component to then solve for what theta was. I'm going to choose the x component for this example. I'll choose the y component for example B, just for fun. So my goal is to solve this equation, since the a coordinate of the u vector would equal the magnitude of u times the cosine of theta. So I got to find the magnitude of u, and now I can solve by theta by dividing by square root 13 and using the inverse cosine. Since both the x coordinates and the y coordinates of vector u are positive, the vector would be in quadrant 1, and I don't have to worry about theta being a reference angle or what quadrant it's supposed to land in, or the range of the inverse cosine, and the answer is 33.69 degrees would be theta, which makes sense from the picture over here. Now I said in part B I'm going to use the y coordinate setup, just again to change things up a little bit, but I've got to first find the magnitude of v, and now I can set up the equation to solve. The y coordinate of the vector v is going to equal the magnitude times the sine of theta. Now this vector has both negative x and y coordinates, so the vector is supposed to be in quadrant 3. So I have to keep that in mind when I put in the inverse sine of negative 5 over square root 29 into my calculator. I get negative 68.20 degrees should be theta. Well, that would be down here, negative 68.20 degrees. And that's not what I'm looking for, not in quadrant 4. But I can use 68.2 degrees as a reference angle for another angle that will land me in quadrant 3. So I could do 180 plus 68.20 degrees, which will be an angle where the vector would be in quadrant 3. So 248.20 degrees would be the value of theta, where I would have a vector negative 2, negative 5 in quadrant 3. Then now try problem number 33, says find the magnitude and direction angle of the vector. First I'm going to find the magnitude because that'll help me find the direction angle. So in this case the magnitude is 5, so again I can use either the x or the y coordinate. I'm going to choose to use the x coordinate, so I will set up 3, the x coordinate equals 5 times, and since I use the x coordinate that will be cosine of theta, and I'll solve for theta. And I get 53.13 degrees, and since the vector 3, 4 would be, since both the x and y coordinates are positive, that would be in quadrant 1, so 53.13 degrees would give me the exact direction angle.